Welcome to the Defense and Aerospace Report. I'm Vago Muradian here at the Air Force Association's annual Aerospace Cyber Conference and Trade Show, the #1 gathering of U.S. Air Force leaders from around the world assembling here just outside Washington, D.C., always coinciding with the birthday of the United States Air Force. Our coverage here is sponsored by L3Harris and Leonardo DRS, and we're here on the Parsons stand, Parsons Engineering, legendary company, to talk to Doug Dreyer, who is the Executive Vice President for Advanced Technology Solutions, and we were joking just a minute ago, as opposed to very low-cost problems. So you have a very, very good part of the business.
Thank you.
Congratulations on joining the Northrop Grumman ground-based strategic deterrent team. It looks like it's the only horse in this race at this point, so we'll see what happens. We'll see what happens. Everybody focuses on the rocket piece of it, the command and control piece of it, but not actually the extensive ground facilities that go with it. And I think it's amazing that 60 years ago, you guys built all of that infrastructure that's in the ground right now. Talk to us about what you're bringing to the Northrop Grumman team and what, and how this program is going to unfold at the end of the day, should you guys be lucky enough to be awarded the contract.
Well, first of all, very excited to be on the team, but the infrastructure piece is something we do. We do this all over the world, whether we're rebuilding in Antarctica or in the North Pole. So we do this kind of work all the time. For the GBSD, it's very challenging from a mission point of view. 450 some missile silos that have to stay active to meet the mission, and they have to be refurbished to look brand new when they're all done. So it's a very important mission, and we're happy to be on Northrop's team.
So everything's got to be manned and up, right?
Right.
But you also have start limitations that go on the tubes. So let's separate what's going to happen on the tube insofar as you can discuss it, because there's a lot, this is still a competition.
Right.
And then what happens on the ground part of it, because even though they're incredibly robust and don't seem to have many problems, it's like any old facility. You take it apart, you're going to find problems. Let's start with the tubes.
Well, the tubes, they go, some 100, let's call it 100 feet in the ground. There's groundwater, there's going to be corrosion, there's steel structures that were designed for maybe 50 years. As you said, they've been in the ground for sometimes up to 60 years. So you got to go in there and repair and make them whole the way they, consistent with all the treaties that we already have. As far as where all the crews are in the launch control facilities, there's a major push to make those much more inhabitable for the crews. They're there 24/7, on watch. So there's going to be a much more of a modernization plan, I guess, for the launch control facilities.
And talk to us about the incorporation of technology in this, because these structures are actually remarkably sophisticated even in their day, because they're facilities designed to withstand a direct nuclear blast. There's not a lot of stuff designed to that degree of solidity, Doug.
Well, we don't always talk about the details of that, but you're right. They have to withstand a lot of the Air Force's survivability requirements. It's very important for the mission. But the technology, we have a 3D printed version of the old designs. We still have the old designs. We were able to take pictures, drawings that were made 60, 70, even many, many years ago, and digitize them, make 3D models. So we're going to be using the advanced digital construction techniques to give the Air Force, the best that industry can offer.
You guys are, as you said, globally known engineering company. You do some of the bigger projects around the planet. What are some of those construction skills, and how technology and construction processes and techniques have changed in the last 60 years? Because you guys could do giant stuff then, you do giant stuff today, you just do it a little bit differently.
Yeah, and I was mentioning the digital technology. There'll be digital twins of down to every bolt, every part, and that'll be totally connected in with the supply chains. There'll be suppliers all over the country providing, whether it's steel or aggregates, other equipment. That all has to be logistically integrated and has to make it on time to meet the schedule on the program. It's a very challenging schedule.
And talk to us a little bit about your growth strategy. I mean, the company has been working very aggressively to expand, to go beyond its sort of classical engineering roots to all sorts of new areas, whether on the cyber side of the equation and others. Tell us a little bit about the growth strategy.
Well, what we found is many of the things that we were doing, even in construction, was the advanced, more complicated technical construction. So when it comes to project management, we've always been strong there. What we've been adding is more cyber technology companies, systems systems engineering with the missile defense program, and also high speed, maybe processing. We don't want to talk about too much, but we do a lot in those spaces. So we're bringing more software, more advanced technologies into our product offerings.
Doug Dreyer, who is the Executive Vice President for Advanced Technology Solutions here at Parsons. Absolute pleasure. Best of luck with the program, and we'll see, right? It's a one-horse race, but we don't know how this is going to turn out.
Well, we'll have to see how it turns out. Thanks.
Thank you.